Hello, welcome back to part 2 of Laws of Exponents. Okay, let's keep trucking with our examples here. We're going to go to example 13, express in exponent form with a prime number base, 25 cubed. So 25, hopefully you can see that we can break down into 5 squared, right? So 5 squared to the third, and we take 2 to 5 squared to the third power is we multiply these exponents. That's going to turn into 5 to the sixth. Okay. 49 is the same thing as 7 squared. So we have 7 squared to the v power, and we again simply just multiply these two exponents here because it's power raised to a power. So that's 7 to the 2v. All right. And then this one here, 9 to the t over 27. So these are both powers of 3 because we can break 9 down into 3 squared to the t, and 27 we can break down to 3 cubed, right? So on the top here we've got 3 to the 2t, and on the bottom we've got 3 to the third. We want to bring that up here to simplify it, so that's really going to turn into 3 to the 2t times 3 to the negative third, and then we simply just add those exponents together, and that gives us 3 to the 2t minus 3. Okay? Right, moving on to some more examples, 14 and 15. Write without brackets. So, anything that doesn't have a power, let's write a 1. Right? So we're going to distribute this 3 times 1 and 3 times 1, so that's going to be 5 to the third. That does not look like a 5. 5 to the third, r to the third for this one. Okay? Same thing here. That's a 1, that's a 1. That is going to be 5. 1 times 2 is 2, and 1 times 2 is 2, y squared. 5 squared over y squared. Or, again, depending on how they ask, you could write it as 5 squared y to the negative second. Either one of those is fine. Okay. 13 to the 0 power. Remember, anything to the 0 power, 1. Okay. 7 to the negative second is 1 over 7 squared. I don't know if that's really simpler or not, but we're rewriting it so it doesn't have a negative exponent. So we'll go with that for now. 2 over 5 to the negative third. So remember, that's 2 to the first, 5 to the first. So that's 2 to the negative third, because 1 times negative 3 is negative 3 over 5. 1 times negative 3 is negative 3. Right? So now what we'll want to do is we'll want to move this 2 to the negative third to the bottom and that 5 to the negative third into the top. So that's going to be, on the bottom is 2 to the positive third, and on the top is 5 to the positive third. Okay? And then this here, 5 to the 0, anything to 0 power, 1, plus 5 to the negative first is 1 over 5 to the positive first. So 1 plus 1/5 is going to be, we can either write it as 6/5 or 1 1/5. Either one is fine. All right? All right, moving on. Example 16, write in simplest form without brackets. So this is negative 2 to the first, right? We want to think of it as that. Negative 2 to the first times t to the third. Remember, this 5 is going to distribute to both of those, so that's negative 2 to the fifth. And then times t to 3 times 5 is 15. Okay? So, write in simplest form without brackets. So we could just multiply that out. Negative 2 times 2 is 4. Times 2 more is 8. Times 2 more is 16. Times 2 more is 32. So 2 to the fifth power is 32. And then you got the 5 negatives. So each pair of negatives cancel each other out. So the first 2 cancel out. The next 2 cancel out. And we're still left with 1. So that's going to be negative 32 t to the 15th. Okay. This one here, negative with all this, and we got, let's do this, 3 to the first, and then that's all the rest of those have their power. So let's just do this. We're going to attach this negative with the 3, right? Because it's the number there. So we're just going to get rid of that and just move it up there with a 3. So this is going to equal negative 3 squared. 2 times 3 is r to the 6th. And then 2 times 2 is n to the 4th. So really that's going to equal negative 3 times negative 3 is 9r to the 6th over n to the 4th. Okay, those do not have any brackets left, so we're good to go. Simplify using the laws of exponents. So this x, let's make that x to the first. 6 times 5, we can multiply, as long as these are all multiplied together and there's no addition or subtraction in there, we can multiply these. 6 times 5 is 30. X to the first times x to the 8th is x to the 9th. Okay? 20a cubed b to the first over 15a to the first b to the 4th. Let's look at this. We can really kind of simplify this with 3 different little simplifications. So 20 divided by 20 over 15 is what? That's going to be 4/3. Right? And really, let's do this. We can just write it as 4/3, not fourths, but thirds. A to the third over a to the first, 3 minus 1 is a squared. B to the first over b to the 4th is 1 minus 4b to the negative 3rd. So we could write it like that. Probably a better way would be, since we have a 4 over a 3, 4a squared. 3 is already on the bottom, and let's move this b to the 3rd down to the bottom, and b to the negative 3rd turn it into the bottom to be b to the positive 3rd. So that's probably our best bet. All right, this one here, c to the 3rd times c to the 5th. Since these are not a power raised to the power, we're just going to add them, right? So it's going to be c to the 8th over 4 times, this is the one where we multiply, c to the 4th to the 3rd power. 4 times 3 is c to the 12th. And then to simplify that, 8, it's c to the 8 minus 12, which is c to the negative 4th, or we could write it as 1 over c to the 4th, either one of those two. Okay? All right, let's take a little comedy video break, and we will come right back.
Then he asked me, would you like to try trifocals? And I'm like, I must have been away a while, because I have no idea what you're talking about. He says, it's exactly what you would think. You can see at 3 different distances depending on where you look through your lens. You can see close, medium, or far away. And I'm like, I can't even imagine getting used to that. There's a book, there's a plane, there's Alpha Centauri! Do people need this kind of range? Is that a flying meadows? Is that a comet?
Okay, let's take a look at some more examples here. Example 18, write without negative exponents. So, let's see, this 3 needs our power of 1 because we have to distribute this negative 3 to each one of these powers here, right? So that's 3 to the 1 times negative 3 is negative 3, and f2 times negative 3 is negative 6. So we have to write without negative exponents. So we have to turn this into 1 over 3 to the negative 3rd goes to the bottom as 3 cubed. F to the negative 6 goes to the bottom as f to the 6th. And this is really probably fine. You could multiply the 3 to the 3rd out and put it as 1 over 27 f to the 6th. That would be fine too. But this works, so just fine. All right, m to the 4th, n to the 5th, p cubed, q to the negative 2nd. If you'll notice, we don't have any similar bases, so we can't combine any of these. All we're going to do is move this m to the negative 4th down and this q to the negative 2nd up, right? So we're going to leave n to the 5th on the top, q to the negative 2nd is going to come up here, not g, but q. Q to the negative, now it's not negative 2nd anymore because it moved from the bottom to the top, so now it's positive 2nd. And then let's see, we already have p cubed down here, and then this m to the negative 4th is going to move to the bottom and turn into m to the positive 4th. And that is that. Write this without a fraction, b to the 6 over c to the 3 plus x. So again, bases are not the same. We can't simplify those that way, but we can leave b to the 6 on the top, and then this 3 to the x is going to move to the top, so it's going to be c, and then we have negative 3 plus x. So we could write it like that, or we could write it as b to the sixth, c to the negative third, minus x, because we're just going to distribute this negative to both of those parts as well. So this is probably our better answer there. All right, last two examples here. Write without fractions. So we have 1, 2, 3 terms up here and 1 on the bottom. So what we're going to do is we're going to split these up into 3 pieces. So it's c squared over c to the negative first, 4c over c to the negative first, and negative 6 over c to the negative first. And then simplify it that way. 2 minus negative 1 is actually 2 plus 1, so that's going to be c cubed. That's c to the first here, right? 1 minus negative 1 is actually 1 plus 1, so that's 4c squared. And then there's no c's up here, so we just move this up to the top, and it turns into 6c to the positive first. So we just end up with that. Okay? And then this last one, 1, 2, 3, 4 terms. Again, I'm going to write all these over t squareds. Make my life, it just makes this so much easier of a problem if I can split them all up. 3t to the fourth over t squared. Oops, and then that's really minus t squared. We can do this plus the negative t squared over t squared plus 5t over t squared plus 1 over t squared. So again, if you can see, it's all of these things here are right there, and they're all just over t squared. So we're going to treat them like 4 different little problems. Okay, so we have 3 t to the fourth over t to the second is 4 minus 2. That's t squared. And then we have minus t squared over t squared. Those simplify down to 1. That's 5t to the, t to the first. So that is plus 5. 1 minus 2 is negative 1. So that's 5t to the negative first. And then this t to the second comes up to the top and turns into 1 times t to the negative second. We don't need the 1 because it just doesn't change anything there. So there's our final answer for that one. Okay? All right. That's all there is for laws of exponents. If you have any further questions, please feel free to ask. Thanks.